Routers. In a previous video, we discussed how it simply isn't practical to set up a direct connection between every pair of computers in a network because there simply isn't enough hardware to support that kind of setup. This introduced us to the hardware known as the router, and we stated that whenever a computer wants to transfer data to another computer, it sends that data to the router, and then the router then forwards that data to the destination. Now, in this video, we're going to dive a little deeper into how routers work because, as you might have guessed, how routers work is a little more complex than what was explained in the last video. So, in theory, we do set up a few direct connections between computers in the network. We just don't set up direct connections between every pair of computers in the network because, as was stated previously, there isn't enough hardware to support that kind of setup. However, there is enough hardware to support just enough direct connections being set up so that there exists at least one route between every pair of computers in the network. So, suppose computer A wants to transfer data to computer E of this network. What computer A will do is send a transfer request to the router, and this request will contain the data that computer A wants transferred, whom that data is coming from, and to whom computer A wants that data transferred to. Then what the router will do is determine which route is the most efficient route for that data to take. Now, you may be asking, what makes a route most efficient? Well, there are several key factors that a router considers when determining which route is the most efficient route to take. One of those factors is obviously distance. Shorter distance is obviously preferable to longer distance. However, that's not the only factor. Another factor is reliability. A route may have a smaller distance, but could also be high risk. It could have a bad history of breaking down unexpectedly. Another factor is connection speed. A route may have a short distance, it could be extremely reliable, but could have an extremely slow connection speed. All of these factors a router considers when determining which path is the most efficient path to take. This also brings us to another important point worth discussing. Notice that there is more than one path between computers A and computer E. There's this path right here, and there's also this path. When your network has more than one path between a pair of computers, we say that that network has redundancy. Now, in most contexts in life, redundancy is seen as a bad thing. It means you're using too many words, that you're using more resources than you need. However, when it comes to networks, redundancy is a good thing because it means we're not putting all our eggs in one basket. It means that if one route unexpectedly breaks down, there's another route ready to do the job when needed. This kind of system is called fault tolerant because it's able to tolerate faults. If a fault occurs in the system, there's a backup plan in place ready to keep the system running. A network that has zero redundancy ceases to work whenever a fault occurs in that network.